Okay, in this video we're going to be solving rational equations. Now when you solve rational equations, there's a couple methods you could use. One of the most common methods is using cross multiplication. However, cross multiplication in Algebra 2 doesn't always work for a number of reasons. First, when you do cross multiplication, there has to be just a fraction equal to a fraction. There can't be addition or subtraction on one side of the equation like you often have in Algebra 2 and above. Second thing, whenever it is when you try cross multiplication, if you're not careful, you could end up with a higher power exponent than what you might be able to handle, or make the problem overly complicated. So cross multiplication isn't the best way to go. Sometimes it works out great, and sometimes it is the most efficient method, but it's not always the best method in Algebra 2. One of the other common methods is to multiply all of the fractions, or all the terms, by the common denominator for all the fractions. And that's the method I'm going to be doing in this video. Now, the main vocabulary I have here is what's called extraneous solution. This is a solution that will sometimes emerge in the solving process when you're solving something algebraically, but it's not valid for the original problem. For example, when you are solving equations like this, it turns out that you're either solving a linear or quadratic equation after getting rid of the fractions, but when you get rid of the fractions, some of the solutions for the linear or quadratic equations don't work in the fractions themselves because they make the bottom of the fraction 0. And that's usually where the extraneous solutions come about for this type of problem. Now, example here, one here is, what is the solution to the rational equation? We have 1 over the sum of x and 4 equal to 2. Now, with this one is an easy one to do with cross multiplication, but I want to actually keep it consistent and use the same method the whole time. But cross multiplication will work great here because it's a very simple fraction. On the right side, we have 2, so as a fraction, 2 would be 2 over 1. And the process that we're going to be doing is multiply both sides by the common denominator. I'm just going to put CD for short. So that's the first step we're going to take. The common denominator in this case would need to have x plus 4 and the 1 as well. So really just x plus 4. So I'm going to multiply both sides by that common denominator. Remember, what you do to one side, you must do to the other. In doing this, on the left side, the x plus 4s are going to end up canceling out, leaving us with just 1. And on the right side, well, we'll actually have to do that multiplication, but for now I'll just write it as 2 times x plus 4. After multiplying both sides by the common denominator, you'll just solve the resulting equation. Sometimes that's a linear equation, sometimes that's a quadratic equation, and depending on what the result is, determines the steps that you actually have to take. In this case, it looks like it's a linear equation, so I'm just going to distribute and then do reverse order of operations. So we'll have 2x plus 8, subtract 8, we'll have negative 7 equals 2x, and then we'll divide by 2. So x is equal to negative 7 over 2. And the last thing we should do is check our answers. And the key thing you want to really check is to make sure your answers aren't extraneous solutions. And the way you do that is you just look at the bottoms of the fractions. If your answers would make the bottom of the fraction 0, that causes a major issue because, as you might know, the bottom of a fraction cannot contain 0. So if we were to try to plug 7/2 into the bottom of this fraction, negative 7/2, negative 7/2 plus 4, well, negative 7/2 plus 4 is not 0, so we are good, and negative 7/2 is indeed the answer. Had it made the bottom of the fraction 0, then there would have just been no solution. Okay, so in example 2, we're asked what is the solution for this rational equation. We're going to start off the same way. We're going to figure out the common denominator so that we can multiply both sides by that common denominator. Now, remember, to find the common denominator, we need to look at the factors. So the left fraction, the factors of x squared minus 4 are x plus 2 and x minus 2. It's that difference of squares pattern, the a squared minus b squared. So as far as the factors that we need to contain in our common denominator, we need both x plus 2 and x minus 2. We will move, once we find the common denominator, we'll multiply both sides by that common denominator of x plus 2 and x minus 2. X plus 2 and x minus 2. Well, a lot of things are going to cancel out here. The x plus 2's are going to cancel out, and so are the x minus 2's for the first fraction on the left there, leaving us with just the x plus 3 from the numerator. And on the right side, the x plus 2's will cancel out, leaving me with 1 times x minus 2. Don't really need the multiplication dot. So now we've gotten rid of the fractions. We're going to solve it like a linear equation. So we're going to go through and distribute, which I really don't have to do because it's 1. Give me x minus 2. This is a linear equation. So we're next going to move all the x's to one side. So I'm going to subtract x from both sides. And what do you know? The x's cancel out, leaving me with the answer 3 equals negative 2, which is not actually a possibility. So the answer for this equation is that there is no solution. Okay, in this next example, our fraction has become a little bit larger here. We're still going to go through it the same way. We're going to need to find our common denominator, which means I'm going to have to factor the denominator of this fraction. And if we go through the process of factoring, we would find the factors are x minus 5 and x minus 3. Now, I know the factors are that because I actually did the process of factoring, not because they are also over here. Though in many of the problems, that's a good indication that those might be your factors. The reason why they are the factors is they do multiply to be the positive 15 and add to be the negative 8. Our common denominator needs to consist of each factor we see in the bottom of the fractions, which are, again, the x minus 5 and the x minus 3. And to finish off the first step, we shall multiply both sides by that x minus 5 and x minus 3. However, with this left side, we're going to have to multiply both fractions by that common denominator. So we will set it up like that, and then have to distribute it through. So it's going to be the first fraction times our common denominator. And x minus 3 plus our second fraction times our common denominator. X minus 5, x minus 3. And on the right side, I'm going to go ahead and cancel stuff out right away here. The x minus 5's will cancel and the x minus 3's, which means our whole denominator is canceled out, leaving us with 2. On the left side, however, I chose to write it out a little bit longer. I don't normally do that as I'm doing these problems, but it makes more sense when you're first seeing one of these problems with a little bit more complicated operations involved. The x minus 3's, the x minus 5's for the first fraction end up canceling out, leaving us with the 1 times x minus 3, which is really just x minus 3. And on the other side, the x minus 3's cancel, leaving us with just x times x minus 5 equal to our 2. We're going to have to go ahead and simplify those before we can actually determine which steps we need to take to solve. So 1 times x minus 3 is x minus 3, and distributing my x through, we'll have x squared minus 5x. Based on the fact that we have a squared there, I'm going to say this is a quadratic, at least for now. So I'm going to go ahead and combine like terms before moving everything to one side. So my x and my negative 5x will combine. And since it is a quadratic, I'm going to go ahead and write it in standard form. But they'll combine to be negative 4x. My minus 3 will come down. Equals 2 will come down. We need to make sure it's equal to 0, so we'll subtract 2 on both sides. We'll have x squared minus 4x minus 5 equals 0. Now this is a quadratic equation, so we could solve it with quadratic formula or zero product property, which is what I usually tend to do because it's usually quicker. So the combination of factors we need are negative 5 and positive 1, making our factors x minus 5 and x plus 1, since we have no leading coefficient. Saying each of our factors equal to 0, we get x equals 5 and x equals negative 1. Now those are just the possible answers. We do still need to check them with the denominators, specifically the factors in the denominators of each of our fractions. So we need to make sure that they don't make any of our factors from the denominators equal to 0. And if they do, they are not actually a solution. So the factors we have to check are x minus 5 and x minus 3. If I plug 5 in, 5 minus 5 will be 0, which is a big no-no. So x equals 5 is an extraneous solution. Which means algebraically it worked out. We didn't do anything wrong. But it doesn't solve the original equation. It solves the quadratic equation that we solved, but it doesn't solve the original rational equation. Then if we go back and try 1 in our two factors, or negative 1 in our two factors, negative 1 minus 5, that's definitely not 0, and negative 1 minus 3 is also not 0, so negative 1 should indeed solve our rational equation. Okay, in this video, we're going to solve another rational equation. Just going through, we're going to find our common denominator first. We currently have 7 over 1 as that middle fraction, and x minus 2 is our other denominator, so our common denominator would really just need x minus 2. We'll multiply both fractions, or both sides of the equation, by x minus 2. Said both fractions, but we're multiplying both sides in their entirety by x minus 2. On the left side, the x minus 2's are going to cancel out, leaving us with just 5x. The x minus 2 on the right side will have to distribute through to both terms, so it's going to be 7 times x minus 2. And it will be plus 10 over x minus 2. Times x minus 2, of which the two x minus 2's will cancel out, leaving us with 5x minus or equal to 7 times x minus 2 plus 10. Now, from the looks of it here, I think it's probably a linear equation, which it is. So we'll distribute the 7, and then we'll solve it like a linear equation. 7x minus 14 plus 10. Going to go ahead and combine like terms. 5x equals 7x minus 4. Since it's a linear equation, we need to move all the x's to one side, so we'll subtract 7x from both sides. And we'll have negative 2x equals negative 4. And we'll divide both sides by negative 2 to finish getting x by itself. So x is positive 2 as a possible answer. Remember, the final step for these equations is to double check to make sure this is not extraneous. So if we check this possible solution in our denominators, which our only denominator really is x minus 2, if we plug it in, 2 minus 2 is indeed 0, which means x equals 2 is not a solution. It's an extraneous solution, which doesn't actually solve the equation. So it's not actually a solution. And since that was our only possible solution, the answer for this equation is, well, there is no answer. And that's it.